Okay, today we're going to look at the production of the hoist winch plunger pin. It's a mild steel rivet, and we're going to case harden the head of it so it becomes a hardened wear resistant surface, and then we're going to cut it to the right length and deburr it. So here it is on plate 3 of your hoist winch drawings. There it is, got the dimensions on it. You won't need to worry about the groove. The groove has already been put in there for you. So we're going to case harden the head and get it to the right length. There's a pictorial instruction sheet for doing this. Okay. And the first thing it says is, using a Scotch-Brite wheel, polish away the small flat in the center of the rivet head. Rotate the rivet shank in your fingers as you change the angle of the head to the wheel. Now, I don't know if you'll be able to see it in the camera, but right in the middle of the very top of the head, there's a little tiny flat spot. And we're just going to blend that in. Okay, so we'll come over here to the Scotch-Brite wheel. Okay, so here's our Scotch-Brite wheel. It's sort of like a grinding wheel and a sanding disc kind of combined. It's a very nice deburring tool. Very, very gentle. Doesn't take material off as fast. So what I'm going to do is I'm going to turn this on, and then I'm going to hold this pin and I'm going to spin it in my fingers as I rotate the head back and forth. I really don't need to do the whole head, but I'm just going to kind of go back and forth. And as I do that, I'll blend that little flat spot out on the top of the head into the rest of it so I don't see it anymore. It's just really a cosmetic thing. Okay. Didn't take long. Alright, now we're going to case harden this. Now what case hardening does is it puts a small amount of carbon into a very shallow depth of the surface of a piece of steel. Carbon's the key to hardening things. If you add carbon to steel, it increases the hardness, okay, up to a point. Okay, so what we're going to do is we're going to open the oxygen valve all the way and the acetylene valve one turn. A half, one. Okay. And then we only need 5 psi of acetylene and 5 psi of oxygen. Now there's the regulator, this current regulator right here has a problem, and I can't reduce the pressure because the screw is stripped. But we'll just leave it where it is. It's about 30 pounds of oxygen, but that's okay. Okay, so we're going to open the red hose, which is labeled fuel on the torch, or gas here. Okay, that's the acetylene. So you're going to open the fuel valve a little bit, just, eighth of a turn or less, just to crack it open. Light the torch. Now there's a bunch of soot coming off, so I add a little more acetylene to get rid of the soot. Then I'm going to open the gas valve a little bit, and I want to get a neutral flame. Okay. Now that's not the flame we're going to use though. So what we want is the instructions say light the torch, put a number 1 tip on the torch, put it in the vise. Notice I've got it in the soft aluminum protector so we don't damage the torch. And it's not tight. It's just enough just to hold it. Okay. The sheet says light the torch and adjust it to a 3x or 3 times carburizing flame. Okay. What that means is you want an excess of hydrocarbons. That carbon, some of that extra carbon will go into the surface of the steel when you heat it. So if I turn down the oxygen a little bit, notice that part of the flame that reappeared, that center part. You got 3 parts. You have the bigger outer envelope. The middle one is called the acetylene feather, and then you can see a little tiny bright cone right next to the torch tip. Okay. The middle one that I'm changing the length of right now, that's called the acetylene feather, and I want it about 3 times as long as the inner cone, roughly. Okay. It's not critical. You want to put on your number 5 shaded lens, and then hold the plunger pin with a pair of pliers like that. Okay. Now what you're going to do is you're going to put it in the flame, keeping in mind this is a very small piece of steel. It'll heat up real fast. We're going to put it in this carbon compound called casement. So what you want to do is you want to heat it up. The sheet says heat it to a dull or medium red. Now, looking through this lens, a very, very dull orange will be a fairly bright red. So I'm tipping the lens up and looking out from under it till I get there, okay? And that's about it. Then you put it, plunge it down in this can of carbon dust. Sometimes it's called carbon salt. For 10 seconds or so. Swirl it around in there, okay? So now we've got this soot, carbon all over the head, okay? Alright, so it says be careful not to melt the head. That's a little tricky. You know, you may melt the first one. Okay, it says step 6, again heat the head to medium red and quench in the carbon compound. Now, you'll notice the flame is bright yellow now that carbon's on there. So you really need your shade of this. So get it up to that medium red again. And back in the salt again. The carbon. Okay, then step 8 says remove the excess carbon and scale using a soft wire wheel. Hot. Oh, sorry, I missed step 7. It says heat for a third time and quench it in water. And try not to heat treat the pliers. Okay, then step 8 says remove the excess carbon and scale using a soft wire wheel. Back over here, the same little grinder that has the Scotch-Brite wheel on it. It's got a wire wheel on the other side. So turn it on, just run that wire wheel around and spin it as you go, and then get underneath the head. Okay, 5 seconds. And now we're going to heat it one more time and quench it in water again. So this will be the 4th time that it's heated. And I turned off the torch. You really want to turn off the oxygen first, then the acetylene. It's not that critical, but that's the right way to do it. Okay, so now in theory we have added some carbon, 10 or 15 thousandths deep on the surface of this thing, to create a little hard outer shell. The inside of the metal is still soft, the interior of the head, because we haven't changed the structure of that. Okay, now it says for step 10 and 11, we're going to come over here and we're going to buff the head on this buffing machine. So we'll take a little bit of buffing compound, apply it to the wheel, and you can see the wheel. And I'm moving the compound around so I don't get a bunch of big chunks hanging off that'll just break off. And then you just take this, kind of like when you were cleaning off the flat on the Scotch-Brite wheel. Rotate it in your fingers as you go back and forth. And work your way around on different parts of the wheel so you use the buffing compound that's on the wheel that we applied to it. So back and forth as I spin the rivet head in my fingers. You want to make sure you're never staying in the same spot on the wheel or you just create a big flat spot. And if I buff for too long, I'll buff away all the metal that has the carbon in it and I'll lose the hard surface. Looks like a little mirror. Okay, that's what we want.